Okay, welcome back everybody to online learning. It looks like we're going to be here for a while. Who knows how long it's going to be this way, but we know at least until the end of the semester. And if we look at the news and the predictions, it's not going to get any better soon, so who knows? So we know now what congruent triangles are. Congruent triangles are triangles that have the same length sides and the same angles. So in other words, if you take two congruent triangles, and lay one on top of the other one, they would line up perfectly. So one way you could prove two triangles congruent would be to prove all their sides are congruent and all their angles are congruent. Well, that would take quite a bit of work. So in the next couple lessons, we're going to learn some shortcuts, which are ways to prove two triangles congruent. And we're going to start out with two ways today. One is called SSS, and S stands for side, side, side. And the other is called SAS, that stands for side, angle, side. So here's the side, side, side postulate. It says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So this postulate is telling you that you no longer have to prove all the sides and all the angles congruent to say that two triangles are congruent. You just have to say, well, if you can show all the sides are congruent, then you can conclude that the angles are congruent. So we'll do an example using that postulate next. So take a look at this diagram, this example, and it says explain why triangle PQR is congruent to triangle PSR. So triangle PQR is obviously the triangle on top, and triangle PSR is the triangle on the bottom. And we're supposed to explain why the two triangles are congruent. Well, if you notice from the given red marks that the top triangle has two sides that are congruent to two sides in the bottom triangle. And so since we know that PR is congruent to itself by reflexive property, we could say that PR is congruent to itself. If you were doing a two-column proof, you would say reflexive property. Now, if you look at the two triangles, now we can conclude that they are congruent. So they're congruent, and that SSS theorem we just had, or postulate, would be the reason. Because if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So that's congruent. Those two triangles are congruent by the SSS postulate. So it's a nice little shortcut. Okay, so we need a little bit of vocabulary here. So the vocabulary today is included angle. So what is an included angle? An included angle is an angle formed by two adjacent sides of a polygon. The polygon in this case being a triangle. So if you look at the triangle that I have here, we would say that angle B is included between sides AB and BC. Okay, so if I move this and I choose this angle, we would say that angle A is included between sides BA and CA. And we can also move over to angle C here, and we would say that angle C is included between sides AC and BC. So that's what it means to have an included angle, and we need to know that vocabulary for our next postulate. Okay, so our next postulate is side angle side postulate, or shortcut for that would be to say SAS. And here's the postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So remember, we no longer have to say all three sides and all three angles are congruent if we can show that two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle. Then we can conclude that those two triangles are congruent. Let's look at an example for that postulate. Okay, so look at the diagram I have up here, and we're trying to explain why triangle ABC, the one on the top, is congruent to triangle DBC on bottom. By the way, notice that the order of the vertices is important. So point A corresponds with point D. Point B corresponds with itself. And point C corresponds with itself when you look at the two triangles. Okay, so we want to say, why are those two triangles congruent? Well, we see already one pair of sides congruent in the two triangles and one pair of angles congruent. But we also know that this common segment here, that those two triangles have in common, is congruent to itself by the reflexive property. So now if you look at that diagram, you see that two sides and the included angle of the top triangle are congruent to two sides and the included angle of the bottom triangle. And so those two triangles are said to be congruent by SAS. And notice the order of those three letters, SAS, tells you that the angle is included between the two sides. Okay, let's look at one more slightly longer proof using one or both of our new postulates. So in this example, you're trying to prove the triangle EFG, so you see that one there. Maybe I can highlight that for us to see that better. Let's do that. So triangle EFG is this one. We're trying to prove that triangle congruent to triangle HFG. So HFG. So it might be easier just to talk about the colors, right? So we're trying to prove the yellow triangle congruent to the blue triangle. Okay, well, and notice that we are given by the red marks that one pair of sides is already congruent, so that's our given statement. If you could write a two-column proof for this, but we'll give the statements and the reasons as we go. Then also notice that segment FG is congruent to itself. That'd be a step in the proof, and the reason would be reflexive property of congruence. Now, notice that the two lines are parallel. I indicated that with the arrows there. So that top line EG is parallel to line FH by given. So that would actually be in the proof if we were doing a two-column proof. But notice this. Notice this angle EGF and angle GFH are congruent. Why? Oh, it's an oldie but a goodie. Here it is. This is why you can never forget any theorem in geometry ever. Here's the theorem. If two parallel lines are cut by transversal, then alternate interior angles are congruent. So notice those two angles that I marked off there are alternate interior angles. FG is the transversal. Okay, so now if you look at the yellow triangle and the blue triangle, you'll notice that they have two pairs of congruent sides. You can see by the markings there. And the included angle is congruent in both of the triangles. So you just met the definition. You just met the postulate SAS there. And again, repeating what that postulate says, if two sides and the included angle of one triangle, that'd be the yellow one, are congruent to two sides and the included angle of another triangle, that'd be the blue one, then the triangles are congruent. And so that's the proof of proving that those two triangles are congruent. So there you go. I just kind of summarize what we talked about in this rather short lesson. We had two new ways to prove two triangles congruent. They're not actually theorems, they're postulates. The first postulate says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. And the other postulate says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. We will have three more shortcut ways to prove triangles congruent in the next lesson, but don't worry about that now. At this point, let's just get some practice with our two new postulates. Okay, good luck.